Here we go, classifying triangles. We are going to be classifying triangles two ways. Let me get a color to write this so it shows up a little bit better. We're going to be classifying two ways. Okay. The first way is by sides, actually by angles. And the second way is by sides. Okay. What does it mean to classify something? To name it? Sort of, yeah. It's a way to arrange or organize things using common characteristics. Okay. I should not hear music while I'm teaching. Please take your earbuds out. You need 100% attention here. Okay. All right. So we are going to begin with classifying by angles. When we classify by angles, we can first off start by talking about an acute triangle. What are you thinking is acute triangle? It's a triangle in which all three angles are acute angles. What does it mean to be an acute angle? Less than 90 degrees. So here is an example excuse me, of an acute triangle. I could give you something like 60 degrees, 80 degrees, 40 degrees, and all of those angles are acute. Therefore, this is an acute triangle. Yeah? By the way, what do we know about all three angles in a triangle? They add up to 180. So whatever we've got there needs to equal 180. So, review, an acute angle is less than 90 degrees. Okay? Any questions there? Okay. We can also have an obtuse triangle. Okay. Now think about this for a minute. If all three angles in the triangle are going to add up to 180, and obtuse is bigger than 90, right? How many angles in a triangle can be obtuse? Can I have two? If I have one angle that's bigger than 90 and I add another angle that's bigger than 90, isn't that already more than 180? So I can't have two because I need that third angle for the triangle, right? And if I have two that already are more than 180, right? Another way to think about it is even if I didn't have obtuse, what if I just had right angles? Let's say this is a right angle and that's a right angle. How am I going to make that into a triangle? You can't. The only way you can do it is by bending those sides in, and if you bend those sides in, they're 90 degrees. They're no longer 90 degrees, right? They're acute. So, an obtuse triangle is a triangle in which one of the angles is obtuse. That's the only way you can have an obtuse triangle. You can only have one obtuse angle. So, if I said this was 30 degrees, and this one was 55 degrees, and this one was 95 degrees. This right here is my obtuse angle. Therefore, I have an obtuse triangle. So an obtuse triangle has one obtuse and two acute. An acute triangle has all three acute. And a review, an obtuse angle is greater than 90 degrees. Okay. Now, I should be a little bit more specific. Mathematically, less than 90 degrees, it's really not just less than 90 degrees. it's between 0 and 90 degrees, because there is such thing as a negative degree measure. You'll learn about that when you get to trigonometry in IM2 and IM3. Greater than 90 degrees, it's really 90 degrees to 180 degrees. Because there are angles bigger than 180 degrees. Okay. We have a right triangle. What's a right triangle? It is a triangle in which one of the angles is a right angle. Now, usually you'll see something like this. That little box means what? 90 degrees. And then your other angles will be labeled, for example, 40 degrees, 50 degrees. And a right angle is exactly 90 degrees. Okay? So I'm going to highlight a couple things because we've reviewed a couple vocabulary words here, right? We reviewed acute, we reviewed obtuse, and now we've reviewed right. And we've talked about an acute triangle, an obtuse triangle, a right triangle, and next, can you say that word? Equiangular. What does that mean? What do you think it means? Equal angles. All of the angles in an equiangular triangle are equal. Okay? So it's an acute triangle in which all three of the angles are congruent. Okay, I don't know what that is. My computer's being weird. Okay. So let's see. In other words, the measures are equal. So, question. If a triangle has three angles, and the angles all have to add up to 180 degrees, and an equiangular triangle, all of them are the same, what's the measure of each angle in an equiangular triangle? 60 degrees. 60 degrees, 60 degrees, 60 degrees. Every single equiangular triangle has 60 degrees, 60 degrees, 60 degrees. Let me know if that pops up again because I'll click it off. I don't know why it's popping up. Okay. Any questions there? Do you notice that each one of these types of triangles, acute, obtuse, right, or equiangular, talks about at least one of the angles in the triangle, which is why these are the names that classify triangles by angles. Now let's get into classifying the triangles by sides. I'm going to change colors. Okay. Classifying by sides. Okay. First kind of triangle, when we classify by sides, is called a scalene triangle. It is a triangle in which no sides are congruent. Or you could say no two sides are congruent. All sides are different lengths. Okay? So if I used my congruent stuff, I would do one line on one of them, two lines on another side, and three lines on the other, showing that they are all different sizes. Okay? If I had something like this, and I drew one, I could say this is 3, this is 6, and this is not. Let's do 8. All sides are different measures. That makes a scalene triangle. Notice it doesn't say anything about the angles, only about the sides. Okay? Still doing okay? All right, let's turn the page over. Okay, next one is an isosceles triangle. An isosceles triangle is a triangle in which two sides, or at least two sides, are congruent. So if this is my isosceles triangle, if I have it marked like that, do you see that these two sides are equal? And then this one's different. Now all three sides could be equal, and that's still technically isosceles, but at least two of the sides need to be equal. When you have an isosceles triangle, these are called legs, and this would be called your base. Okay. So? The two legs include a vertex. We're all good there. Yeah? All right. Next one. This is the last way to classify them. Equilateral. So equiangular was equal angles. Equilateral is a triangle in which all three sides are congruent. So it would be marked like this. Okay? All the sides are congruent. If you put numbers with them, you could say 12, 12, and 12. All the sides are the same length. Okay? So what are how many options do we have for angles? We have 4. We could call it an acute triangle, an obtuse triangle, a right triangle, or equiangular. Those are our angle options. For sides, we have scalene, isosceles, and equilateral. So 4 options for angles, 3 options for sides. So, step 1, question 1. Classify each triangle by its angles and by its sides. So let's start off with angles. Those are my pink ones. I have 4 options, right? So let's look at this. I have acute, acute, acute. What do I have? Acute triangle. And what about its sides? They are all the same. None of them are the same, aren't they? So what would that be? Scalene. So I have an acute scalene triangle. Okay, what do I have next? Look at the angles first. 34, 34, and 112. That's not acute because one of those angles is not acute. It's not a right triangle because I don't have a 90-degree angle. That would be an obtuse one because I have an obtuse angle, the 112. So I have an obtuse triangle. Okay, what about the sides? I notice I have 2 sides that are the same. If I have 2 sides that are the same, isosceles. So I have an obtuse isosceles triangle. All right, let's look at angles over here. Do you see the markings? I know they're kind of light, but this angle is marked as congruent to this angle. This one is not, however, included in that. So it's not equiangular, right? What is it if I have 2 that are the same? Does it say anything? Well, it doesn't say anything there. But I can tell this is not a right triangle, right? Are any of these bigger than 90 degrees? No. So what does that mean? It's another acute triangle. And let's see, I have this thing right here being marked. So what does that mean about the sides? Isosceles. All right, how about this one? What do I see? I see this right here. What does that mean about angles? It is a right triangle. Now, looking at these ones, it looks like, do any of the sides look like they're the same length? Mm-mm. Now, this is kind of tricky because nothing's marked, but if they all look, all the sides appear EAR to have different lengths, so what would we call it? Scalene. So? Okay. Now let's look at these graphing ones. Find the measures of the sides of triangle KPL and then classify the triangle by its sides. So we're not talking about acute, obtuse, right, equiangular. We're talking about classifying it as scalene, isosceles, or equilateral. Okay? So first thing we're going to do is plot these points. So point K is -3, +2. Yes? Point P is 2, 1. And point L is -2, -3. So that right there is my triangle. Let me get a ruler so I can make my triangle nice and straight. Okay. Now, how the heck do I find the lengths of those sides? The distance formula. Remember, the distance formula shows you the length or the distance between 2 points. So, quick little reminder of your distance formula. In fact, I'm going to highlight it so you can remember it. Seriously? ESPN doesn't matter until you graduate high school, right? Okay, so if you remember, the distance formula is the square root. Remember, it was this super long square root? And it was x2 minus x1 squared plus, thank you, y2 minus y1 squared. That was my distance formula. So, if I have a triangle, how many times am I going to have to do the distance formula? 3 times. So, I'm going to start off with side KP. Okay? KP is going to be the square root of, now I can look up here for the values of x and y, right? So let's see, 2 minus -3 squared plus 1 minus 2 squared. X minus x, y minus y. 2 minus -3 is 5 squared. And 1 minus 2 is -1 squared. And 5 squared is 25, plus 1 is 26. So KP is radical 26. Anybody know what radical 26 is? Approximately? What's the closest square number to it? 25? What's the square root of 25? 26 is a little bigger than 25, so this is 5 point something, right? 5 point something, probably like 5.1-ish. We'll see if I need to get more specific than that. Okay? All right, let's try another side. Let's try PL. So again, x minus x, so -2 minus 2 squared, plus y minus y, -3 minus 1 squared. So That would be negative 2 minus 2 is negative 4 squared plus negative 4 squared. Yeah? Gives me the square root of 16 plus 16 is 32. Now, quite frankly, I think it's going to be easier if we just go to decimal form. So let's see. What is the square root of 26? 5.09. What's the square root of 32? 5.66. So far, I have two sides that are different lengths, right? Which means I'm either going to have isosceles or scalene. If this side ends up being 5.09 or 5.66, I have isosceles. If it ends up being something different than those, I have scalene. So let's find the last one, KL. So the square root of, let's see, KL, negative 2 minus negative 3 squared plus negative 3 minus 2 squared. So let's see, that becomes negative 2 plus 3, which is 1 squared, plus negative 5 squared. 1 squared is 1, 5 squared is 25, that's 26, that's root 26. We already found out the square root of 26, didn't we? It's 5.09, so what do I have? So, I'm going to say right here, I'm going to say for part A, it says find the measures of the sides. So side KP is radical 26, which is approximately 5.09. PL is radical 32, which is approximately 5.66. And then finally KL is radical 26, which is approximately 5.09. And for part B, classifying, I have an isosceles triangle. So? Okay, you try number 8. It's not a lot of work. It's 3 calculations. Come on, people. So I'm slowly working through this. Feel free to follow me as you're doing it. Okay? Okay. Negative 2 squared, and then 4 minus negative 3 becomes 7 squared. That's 4, and 49 is 53. So KP is radical 53 Square root of 53 is about 7.28. Okay. All right, PL. Negative 1 minus 3 squared plus 1 minus 4 squared. That is negative 4 squared plus negative 3 squared, which is 16 plus 9, which is radical 25. So PL is radical 25, which is exactly equal to 5. So let's see, KP is 7.28. PL is 5. And now my last one, KL. So let's see. Negative 1 minus 5 squared plus 1 minus negative 3 squared. Totally running out of space there. That gives me negative 6 squared. And then 1 minus, that's 4 squared. So that's 36 and 16. So that's 36, 46, 52. Which is approximately, what kind of triangle do I have? Do I have isosceles? Those two are really close, but this is not isosceles. This is scalene. They are all different lengths because radical 53 is not equal to radical 52. It cannot be isosceles. Okay? All right, so let me explain your homework to you really quick. Your homework on the top, it has 4 problems that say classify by angles and sides. So you'll have 2 words to describe them. Here you will also describe by its angles and its sides. The difference is this one has some angles in there. This one has just the markings. And then you have 2 problems like we just did. And that's it. Okay? All right? Happy studying.